As you can probably imagine, after millions of years of extinction, finding out about an animal's diet is very challenging. However, when possible, information about the dietary habits of deceased giants can provide insight into their past and the history of our world. A multinational team of scientists led by the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany, investigated the nutrition of the legendary Megalodon, the largest shark to ever swim the Earth's seas. This new method looks at the zinc isotope composition of the heavily mineralized region of teeth, which is particularly useful for determining the diet of extinct animals. Megalodon lived between 23 and 3.6 million years ago in oceans all over the world and could grow up to 20 meters long. To put that in perspective, today's largest great white sharks are barely 6 meters long. Many theories have been proposed to explain Megalodon's gigantism and extinction, with its food and dietary competition frequently cited as major reasons. Researchers looked at zinc-stable isotope ratios in modern and fossil shark teeth from all across the world, including Megalodon and present and fossil great white shark teeth. The trophic level of an animal, which determines how far up the food chain it feeds, can be determined by the analysis of such isotopes. The team compared the tooth zinc isotope signatures of extinct early Miocene, 20.4 to 16.0 million years ago, and early Pliocene, 5.3 to 3.6 million years ago, species to those of extant sharks using this new method. The researchers next looked at the zinc isotope ratios in Megalodon teeth from the early Pliocene and Miocene, as well as contemporaneous and present great white sharks, to see how these iconic species impacted past ecosystems and each other. Our findings revealed that both Megalodon and its ancestor were apex predators feeding at the top of their respective food chains, says Michael Griffiths, a professor at William Patterson University. However, zinc isotope values from early Pliocene shark teeth from North Carolina imply that early great white sharks and the much larger Megalodon had virtually overlapping trophic levels. These results likely imply at least some overlap in prey hunted by both shark species, notes Kenshu Shimada, professor at DePaul University, Chicago. While additional research is needed, our results appear to support the possibility for dietary competition of Megalodon with early Pliocene great white sharks. Zinc isotopes, for example, provide a unique look into the past. Our research illustrates the feasibility of using zinc isotopes to investigate the diet and trophic ecology of extinct animals over millions of years, a method that can also be applied to other groups of fossil animals including our own ancestors, concludes McCormick. While this is not yet Jurassic Park, it shows how far we can look back to examine the history of our planet. And with this information learn from the past to perhaps help our future. If you enjoy this type of video, please consider subscribing.